Now you probably noticed that on the trail, the deposits we saw were kind of rocky, right? In some places. Now not so much right here, but at least on the way down they were, and I picked up a couple of them. One's kind of smooth. It's a piece of lava rock from Mount Hood. The other's kind of angular, and really angular. In fact, it's kind of rough. And this is a pretty good example of the kind of rocks that are carried by volcanic mud flows, which we call lahars.
Hold on for a picture. Picture? Hold on.
Okay.
Thank you.
Yep. That's it.
Been on a couple of these TV shows, you know, like for Discovery Channel and stuff, and it's always so funny. Could you?
I'm getting some good shots.
Could you look over this way when you say that? Oh, okay. One of the favorites was they go, "Could you say that again?" I said, "I just made that up." Well, I said, "We'll make it up again," because like an airplane flew over, so the sound guy goes, "Cut." So everything I just said is like gone because they don't want to use it. It's a wild camera, man.
It is.
Holy cow!
It's just an iPhone.
That's really cool. Looks futuristic to me. Okay, enough of these rocks. So, what are we looking at here? Wind the clock back to 1805. About November 1st, October 31st, November 1st, 1805. Some folks dressed in some very tired, weary-looking folks, dressed in leathers and so on, arrived here, Lewis and Clark, with their crew. And they had come down through the gorge, end of their long journey. By this time, they knew they were close to the ocean, because when they got to what's now Cascade Locks, which will be our last stop, they started noticing something. The tide was the influence of the tide on the river, on the Columbia River. So they knew they were very close to, this was totally exciting to them. If you've read their journals, this part of their journals, it's really cool because they're writing about this area. Well, they got here to the Sandy River. They didn't call it the Sandy River though. When they got here, their descriptions were they had a real hard time getting through here. They said this area was nothing but quicksand, and it was very unusual. They were very intrigued by it, and they named this river, in fact, the Quicksand River, because it was totally choked and clogged with sediment. Now, when I was put on this Mount Hood hazards team in 1983, we found out that Rocky Crandall had dated some of these volcanic debris flows, these lahars that came through here, and he dated them with radiocarbon dating to about 250 years old or so. Now, radiocarbon dating, especially back then, it's better now. But even 30 years ago, it was a little fuzzy, and meaning that if 250 years ago could be plus or minus a century, or plus or minus 50 years. You really don't know, especially when you calibrate the date, because when you get a date back from the lab, that's just and they weren't actually calibrating the dates in 1981 when Rocky put out his report, or 1980, whenever that was. Because they didn't really come up with a calibration scale until 1986. In fact, the University of Washington Radiocarbon Lab and the one in Belfast, Ireland, started working together on calibrating the radiocarbon timescale. And what they were doing was they were taking individual tree rings of a known age back to they first started back to like 2,300 years ago. And they would date each ring with radiocarbon, and they developed this plot, this graph, that showed the radiocarbon calibration curve. And the reason that was important to do is that's how they found out carbon-14 changes in the atmosphere through time. And so that anytime you get because we know we use radiocarbon because it has a half-life of 5,730 years. So when we get a piece of wood that we find buried, say we find a charred branch that was carried down by the eruption, right? We send that wood into the laboratory, and we get a date back, and that simply says the amount of carbon-14 to the amount of carbon-12 tells us, with a half-life of 5,730 years, how much time has elapsed. But what it doesn't tell us is how much carbon-14 was in the atmosphere when that tree was formed. And that has an influence on the date. So the calibration scale hadn't been developed. So what I'm trying to say is, this is how fortunate we're below this tree right now. Which is an oak tree.
It's a nice oak tree.
This is a wonderful oak tree. This is a Gary oak tree.
It's made of knives.
Marvelous.
Nice.
This is the Oregon Gary oak. This is a marvelous tree. So this is the tree that's native to a lot of prairies around here. You know, this is really, really neat. So, so anyway, that date, 250 years, is fuzzy. That's the important thing to know. So when we were here and we saw my friend Ken was the one who really noticed this in Lewis and Clark's journal, this bit about the Quicksand River. So we said, wait a minute, Quicksand River, lahars are only a couple hundred years old. That is unusual. I wonder if there's a relationship, like they got here maybe right afterwards or something. So this led us on a quest to try to figure out, and we eventually went up and found buried trees in the same layer that is the topmost layer here. And we were able to date that using tree rings to 1781. So that's just 24 years before they got here in 1805. So we ended up publishing a few papers, first saying in the 1980s, saying that we thought it was, you know, sometime in the late 1700s based on tree rings, but we hadn't at that point found a tree with bark on it yet that was buried. So we were not confident we knew the exact year. But then in the late 90s, I found a tree with bark on it. Found two trees with bark on it. So this is like, you know, 15, 20 years later, I'm still working on this project, 15 years later. And I came down here, by this time I'm working for the State Geologic Survey, but I found these trees with bark on it so I could tell the exact year. So finally in 2002, I published a little abstract at the Geologic Society of America meeting in Denver that year, the national meeting, that said, you know, 1781 is when this eruption happened, because that's what we figured out. So that was, and then we finally, just a couple years ago, I wrote a whole paper on this that was in a book, a tree ring book about this eruption. And then we had another paper that was in the Geologic Society of America journal on this. So, I mean, if you want to look at those papers, I can make those available. But the point is, it takes a long time to do that. So, so anyway, what we're seeing here, the uppermost unit or layer is, and this is steeper than what was last year, is the layer that came down just in 1781. And it's kind of a fine-grained layer. You saw that where we walked on it farther up, it's a lot more coarse-grained and has bigger rocks in it. Here it's just kind of sandy. But there are some big rocks. Here's one, for example. Here's a rock that is 2 inches wide, right here. And it's a Mount Hood volcanic rock. So, but if you looked at this layer, one of the things you see is there's hardly any soil development on it at all. It's just, it's got a little bit of organic material. There's not much yellow weathering because it's only a couple hundred years old. So this, here, you see these roots coming out down here? This is the bottom of this soil layer, right here. In other words, from here on up is the stuff that came down 200 years ago. This stuff is an older layer. In fact, if we start looking at this carefully, we would see there is a buried soil here. Remember, soil is the weathering that happens on top of a geological layer as it's exposed to the atmosphere, right? So before 1781 AD, this layer here was the top of the ground, right? Down here. So this layer was exposed to the atmosphere for a while, and those of you that can see this, look how yellow this is here. See that yellow color? That's weathering. That's the development of a soil on top of this stuff. And this goes down, actually, that's a pretty good soil. It's yellowish, it's oxidized. I can see some charred wood here. And here's what it looks like when you get about a half meter down or so. It looks pretty much like that deposit up there. It might be a little bit pretty yellow. But so here we've got, essentially, it turns out these down here are lahars from Mount Hood too. They're much thicker. These go almost down to the river. There are a couple big ones right here. These were huge eruptions. So this upper unit is what we call the lahar deposit from the Old Maid eruptive period. And it's called the Old Maid eruptive period because There's a landform, a flat valley bottom up on the west side of Mount Hood called Old Maid Flat. That's the geographic name of this area. Some early settler must have named it. And that layer, that area is all these kind of deposits that are, formed from the 1781 eruption. So that name was given to that eruption. Now the stuff down here is from the next previous but bigger eruption called the Timberline eruption. And the Timberline eruptions of Mount Hood were about 1,500 years ago. So we don't know exactly when, but somewhere, say, 500 AD or so. And that's when the entire southwest side of Mount Hood collapsed and came down in a big mud flow, which is down at the bottom here. And then these big pyroclastic flows created big, giant pyroclastic flows on the volcano. Those hot, fiery flows created huge lahars, which is what these units are. Now look how thick this is. It starts right here. Here's the top soil, this yellow stuff that's developed on top. You can see how yellow it is. Look at that. That's a huge soil layer there. That's 1,500 years of soil, that yellow oxidation right there. And it's developed on top of this sand, but if we would dig down, we'd see this sand gets coarser, and look how firm it is. But it's full of gravel, full of angular deposits. Remember that stuff we looked at on the way down to Mud Mountain Dam, that gravelly angular sand? That's this stuff right here. It's very, very similar to this. So if we would have dug out through the blackberries, that area at Mud Mountain Dam where we hiked down, and I remember I was down there under the blackberries digging it out in this huge thick sand layer. This is the same stuff. Except this isn't from Mount Rainier, this is from Mount Hood. And what's interesting is you go down here, it gets more and more coarse and bigger and bigger particles.
Yep. So.
Let's see if I can actually get down to the bottom of it. But you get kind of a good view of this deposit from down here. You can see it actually holds up pretty well. If this were just loose sand, you wouldn't get a steep cut bank like this. This is actually pretty hard. Because this all came down as one huge debris flow. The one below here, now this one is very loose and sandy because this was created by the type of eruption that is hot pyroclastic flow, a hot flow of rocks and volcanic gas on top of a glacier, melting snow and ice and creating a very sandy lahar like this. The one below here, or maybe two below here, is really sticky clay, and that's the one that was from when the summit of the mountain collapsed, or the southwest flank of Mount Hood collapsed and began to flow. It actually forms the lowest lahar in this timberline sequence. So it's like a debris avalanche that actually kept going as a big muddy lahar, came all the way down to the Columbia River. So this must have pushed the Columbia River, this big timberline eruption must have totally pushed the Columbia River over toward Kamaswashugal. I mean, it was really huge. Even the little Old Maid eruption on top pushes the river way, way up there. In fact, even before Lewis and Clark got here in 1805, in 1792, when Vancouver's ship was here, there was a guy named Broughton who rowed a boat up the Columbia, at least this far, perhaps a few miles up the river. In fact, they named this the Bearings River, not the quicksand. And they were doing soundings right off and Broughton's crew was doing soundings in the Columbia River, right at the end here where the modern Sandy pushes out. And they were noticing how shallow it was out there. So we knew, we suspected, I should say, that the eruption happened before Broughton got here in 1792, because already they were talking about how far north the channel of the Columbia was pushed and how shallow it was out there because of all this stuff that was coming out from Mount Hood into the Columbia River. Of course, they did not know Mount Hood was a volcano either, and neither did Lewis and Clark, so they could not explain where all the quicksand came from. Well, it's this volcanic debris. Imagine, it's almost like when you see the Toutle River at Mount St. Helens right after the eruption, all that debris that would have come down from Mount St. Helens, that's exactly what Lewis and Clark saw, except it was right here, and it came from Mount Hood. So, I just want to grab some of this stuff, and you can get an idea of how gravelly this is here. I don't really see any big chunks. There's actually some clods of... I can't tell what this is. Here's it. You want to just hand that up and...
wonder if it's colored as bright as that stuff was when you dug up.
Pardon?
I wonder if it's colored as bright as that stuff was when you dug up. That's the last stuff we did last year. That stuff was impressive.
Yeah, this stuff looks a little different than the mountaineer
Hold it
stuff.
for somebody.
I say we should stay here a few minutes till the rain stops. What if it starts raining harder?
Yeah.
I don't think it's. I don't know. It's gonna. Who cares? Field trip.
It's gonna be that kind of day.
Yeah.
Now I understand why you buy the